everyone. Today we are learning day 11, solving rational and polynomial inequalities. And so I have a quick picture right here that shows us a couple things about a rational polynomial and just where the inequality piece will come in. So first, we see this graph and it has positive answers. So I'm going to write f of x is greater than 0 from negative infinity to negative 3, and then from 5 to infinity. And so that is all the positive values. We've done this before with just looking at the graph of looking at the positives and negatives of a graph in general. And then it's underneath the y-axis right here, the x-axis right here and here. So that's negative from negative 3 to 2, and then from 2 to 5, because at 2 it equals 0. And so that is there. And then I'm going to add then that it equals 0 here. This is y equals 0. Or I want to write f of x equals 0. So that's going to be important to us as we go through. Every f of x equaling 0 is like our critical values for figuring this stuff out. So we have some steps that we're just going to go ahead and write down, and then we'll practice those steps as we go through. So first, our first step will always be to do what we've been doing this whole unit first, which is to factor. See if I can fit it in this box. So we want to factor first. And then once we factor, we're going to determine the critical values, just like I showed on the graph, that make the function. And so what we were looking at was when the function equals 0. And so that is what goes in part A. And we're also doing rational functions, so we'll also look at what makes it undefined. And then we are going to use these values to make a number line. And then number 4, select the x value between each critical value and evaluate the function. I'll model that as we get closer to it. And so if f of x is negative, then the sign is negative for that interval. So we're going to write, I'm just going to put a little note, f of x less than 0 like we saw on the other page. And then if f of x is positive, then the sign is positive for that interval. So positive is a greater than 0. That's how we indicate positive. And then our final answer will be an interval of x values, like I showed. Like I showed on the objective page. And so that's how we'll write our final answer for every problem. So let's do one. We have solved the inequality, use a sign chart, that's the number line that we were talking about, to help. And so we will get started with that. First step, remember, look back at your notes to factor. So we have x minus 3 times x plus 2. And so then those are our critical values. And so what we do is we just put those on the number line in order. So it would be like negative 2 would come first and then 3. It doesn't have to be perfect. Then we choose values in all the different spots to see what makes this true. So I'm going to start with negative 3. I like to just put a little note to what value I picked. I always just go the number right below. And I'm going to plug negative 3 in for x, and all I care about are the signs. This is positive or negative. So if I do negative 3 minus 3, that's a negative. If I do negative 3 plus 2, that's also a negative. And a negative times a negative is a positive. So that's all we really care about. Next, I'm going to put the number between negative 2 and 3, which the easiest is always 0 when you go from a negative to a positive. And so this one's easy because I have a negative times a positive, which will equal negative. And then I'll put in the number for x right above 3, 4. So 4 minus 3 is positive. 4 plus 2 is positive, and a positive times a positive is always positive. So what we really care about is just this overall sign of the value after we've plugged in a number there. And so it will follow that pattern for any number that's below -2, any number between -2 and 3, and any number higher than 3. So what we want to see now is when is f of x less than or equal to 0? So we're looking for the negatives. And so less than or equal to 0 is this negative, or equal to means I'm going to fill in my values because it can equal 0 at those spots. And then I'm just going to kind of shade between. And so that's from -2 to 3. F of x is greater than 0. We'll use the green again for positive. So it's greater than 0 where it's positive here and here. And so I'm just going to shade that. They'll be greater than 0 every time. X is less than -2 or greater than 4. And here I'll use open circles because greater than doesn't have the or equal to. So if we put that in interval notation, that's -infinity to -2, and then 3 to infinity. So really fun stuff. I love these problems. All right, let's do another one. First step is still to factor, but it needs to be equal to 0 before we do. So we will move over that 48, and then we'll factor. And then we'll write x squared minus 16 and 2x minus 3. And finally, we can factor that last one a little bit more. So we take each of these factors and find when they equal 0, which will be our critical values, and we want to put them in order. So I'm going to do -4, 3/2, +4. And so that's our number line. And then what we'll be doing is guessing and checking different numbers that are below, between, and above each of those. So we'll start, I'll start with -5. If I plug in -5, I'm not going to show all my work this time. I'm just going to talk it out. That's a negative times a negative times a negative. An odd number of negatives equals a negative. Next, I'll plug in 0, and I can see easily when I plug in 0, I just have to look at the numbers, -4, +4, -3. There's 2 negatives, that makes it a plus. And then 3/2 is 1.5, so I'll plug in 2. That's between 1.5 and 4. And so 2 minus 4 is negative, 2 plus 4 is positive, and then 2 times 2 minus 3 is positive. So we only have 1 negative and 2 positive. That's a minus. And the number above 4, I'll just go with 5. 5 minus 4 is positive, 5 plus 4 is positive, 10 minus 3 is positive. So all positive there. All right, and then this particular problem is greater than 0. So that's all the positives. And so I'm going to highlight these on my number line like that. And then greater than 0 doesn't include it, so I'll do open circles. And then we'll now put this in interval notation. So -4 to 3/2 union with 4 to infinity. One thing I want to do now is just show you guys a couple graphs with the first few problems so you can see how all of this looks on there. So we'll start with this particular one since we're fresh in our minds. So I'm going to just pull up the graphs. And this is the one we just did. And the question was, when is it positive? And you can see on this graph that it's positive here from -4 to 1.5. And then it goes back down under the x-axis, and then it'll be positive forever from 4 to infinity. So that's another thing as a double checker. And then we can look back at that first one as well. This one right here. I'll unhide that one. So here were our critical values, -2 and 3. And then we wrote 2 answers to that. We wrote the negative answer and the positive answer. So you can always check Desmos to see how you did on problems like this. And we'll check back with our graphs as we go along. Okay, so next, I want you guys to take the next couple of minutes to try these 3 problems. They're all kind of different and strange, and I want you to solve them and figure out what's unusual about them. So pause the video, try these 3, and then I will show the answer along with some graphs when we get back. Okay, so for the first 2 on the left side, when we solve these are perfect squares. And so the perfect squares, if you notice how every other time it went negative, positive, it always alternates. But when you have perfect squares like this, that's not the case. And so you have to be careful and not to just assume it'll always alternate. You gotta just make sure you check. And so here we wondered when does x squared plus 2x plus 1 less than or equal to 0. It's only less than or equal to 0 at -1 where it actually equals 0. So my answer was just a bracket with 1 value in it. And then the next one, we have negative infinity to 2 and then 2 to infinity because it's always above 0, but there was no or equal to. So x isn't equal to 2 here, and so we had to exclude it, like an excluded value. And then this last one on the right, if you try to factor it, you can't. And so I did a quick little quadratic formula. And if you see here, I didn't even finish it because I noticed that 9 minus 20 would be negative. And so it's imaginary, and we want to check the graph for that last one. And so let's go ahead and see what the graph shows. And so we have this graph right here. This is the one we were looking at. And so when we graphed x squared plus 3x plus 5, the question was, when is it negative? When is it less than 0? And it never is. And so if it never is, then we will put no solution or the empty set, either one, like that. And we can just check the other 2, x squared plus 2x plus 1 and x squared minus 4x plus 4 while we look at this. So let's look at that one. See how it's right on the x-axis. And the question was, when is it positive? 0 is not positive, so not there, but everywhere but. And then this other one was, when is it negative? This one was, when is it positive? Everywhere but 2. And this green one was, when is it negative or 0? And it was only 0 at -1. So the graphs can help you see what the solutions are when we look back at the problems themselves. So be sure to check those out if you want to see them in more detail. We're going to move on to some, what are these called? Rational expressions. Okay, so first up, I am going to solve this inequality. 2x plus 1 is greater than 0. Now, when we did solving rationals and we were solving for the x-intercept, for example, we could just kind of ignore the bottom and set the top equal to 0. So I know x equals -1/2 from that. But the bottom parts are important as well, because if we're looking for when is the interval positive, x equaling 1/2 would not be enough for my number line, because here's -1/2. Here's -1/2, and it's positive here and here. And so we're going to miss that other piece if we exclude the bottom of the fraction. So what we do, remember, the rules were to find where the function equals 0 and where it's undefined. So we're also going to say that x cannot equal -3 and 1 for our number line, because it's really important for us to think about the undefined and the solutions at the same time. And so we're going to put this in order. -3 would go first, -1/2, and then 1. And we'll do the same exact process. So I pick a number that's less than -3, like -4. I plug it in. That would be a negative over a negative times a negative. This is going to work out the exact same way as the polynomials. If you have an odd number of negatives, it's negative. If you have an even number, it's going to be positive because they'll cancel out. Between -3 and -1/2, I'll pick -1. That one. I'm not going to show all that work. It's still -1 will be a negative, positive, negative. There's 2 negatives that time, and so that makes it a plus. Then from -1/2 to 1, we have 0. And so there I can see there's only one negative. That makes the whole thing a negative. And then the last one, I'll pick 2. And we have positive, 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 so positive. And then if you look, I will see when is it positive? So that's all here and here. And this number line matches exactly what we're seeing on that graph. I'm going to use open circles for the -3 and the 1, no matter what the inequality says. And then because the inequality doesn't have an or equal to sign, I'll use another open circle there. So my final answer is from -3 to -1/2, and then from 1 to infinity, which we would have missed that 1 to infinity and we would have also missed the -3 if we hadn't thought about those asymptotes when we did our answer. Okay, so pause the video anytime you need to. If I go too fast, we're going to move on to the next problem. Here we have a rational expression, and we want to know when is it less than or equal to 3. And everything we're doing is about positives and negatives. And the whole point is that we want to just do some quick math to see if it's positive or negative. I don't want to do the math and find out if it's bigger than 3 or less than 3. So what we're going to do is make this equal 0 first. Oops. And then this is going to be a little different than when we solve equations. When we solve equations, our goal is to get rid of the denominator. But with a problem like this, we don't want to get rid of the denominator because we need it when we do our number line. And if we get rid of it, we won't get the right answer because that 5 asymptote will cause some weird things to happen. So what we're going to do instead is we're just going to get common denominators. So we're going to multiply this 3 by x minus 5 over x minus 5. And so that gets us 2x minus 7 minus 3 times x minus 5 all over x minus 5. And then we'll want to simplify this. So we want to distribute. And then we will simplify more. And then we want to keep factor properly. And we'll go ahead and take out that negative right there. Okay, now we can follow the rest of the rules. We have a number line. If I look at my 0, I know that x equals 8, and then I know that x cannot equal 5. So 5 and 8 are my 2 values of interest. A number less than 5 is 4. If I plug in 4, I get a negative, but then I multiply it by a negative, it becomes positive. And then on the bottom, I get another negative. So that's a negative. I plug in 6. 6 minus 8 is negative, times a negative is positive, and then 6 minus 5 is positive. So it stays positive. And then 9 minus 8 is positive, 9 minus 5 is positive, but then we have that negative out front. And so here is our stuff. And now we're looking for when is it less than or equal to 0. So that's here and here. And I like to wait till the end to do my circles. It cannot equal 5. And it says less than or equal. And so I'm going to cover in the 8 like that. So my final answer in interval notation is negative infinity to 5 parentheses with bracket 8 to infinity. And let's just check that one on the graph so you can see how it connects. So on this one, I went ahead and just subtracted the 3. See if I can get it to graph for us. There we go. And so it's negative forever until we get to our asymptote, 5. And then it becomes positive until right here at x equals 8, and then it becomes negative again from 8 until infinity. And so the graph will always back you up from your answer, but we will want you to be able to do this mathematically, algebraically, and graphically. All right, almost done. So for the next three, we're just looking at the graphs to talk about this. So this one says, when is it? We have some weird type of graphs with square roots and absolute values. And so for this first one, we're not going to worry about the algebra. I just want to make sure we know how to use the graph. So when is it positive or equal to 0? And what we can see here is that it equals 0 there. And then again here, and then it becomes positive after that. And so we don't need to do the sign chart here. We can just use the graph. That's going to be at -1 only, and then from 3 to infinity, a bracket around the 3. And so that looks a little weird, but we can use the graph to help figure that out. So at -1, it equals 0. So or equal to is important. And then again, it equals it at 3, and then forever to infinity. Okay, so let's move on to one more. I want you guys to look at this graph and try it yourself. You can pause if you'd like, and I'll go over the answer in 1 second, but go ahead and write a quick answer down just so you can see if you're going to get it. Okay, we're not going to use the graph to justify, just to do it. We don't need to do the algebra. We want to see when is it negative. So it's negative here, and then right there, it equals 0. It's undefined at -3. And so if I write my answer, I'm going to write negative infinity to -3, -3 to 2. And we're using the graph, but I'm also letting the equation help me as well. Okay, well, that's pretty much it. What I want you guys to do now is try this closure. You're going to work through the whole thing, construct a sign chart, and then construct a sign chart, use interval notation, determine where it's positive, where it's negative, or equal to 0 on that last one. And then we are going to have you submit your work in Canvas just to see how you did. So thank you for listening. I hope you have a great day, and we will see you soon.